This is the question from the past paper. The diagram in the answer space, this is the diagram, is a map showing the section of the coastline and a beacon on land. This is the beacon here, and this border line is the coastline, and this gray area is the land area, and this white area is sea. Fishing boats can only operate when they are not more than 6.5 kilometers from the beacon, at least 2 kilometers from the coastline. The scale of map is 1 centimeter to 1 kilometer. Construct the boundaries of the region where fishing can take place. Label this region F. Scale is 1 centimeter to 1 kilometer. So 6.5 kilometer is equal to 6.5 centimeter. Fishing can take place only when they are not more than 6.5 centimeter from the beacon. 6.5 centimeter from the beacon is a point. So 6.5 centimeter from one point, it is a circle. First we have to draw a circle. 6.5 centimeter radius. So the compass is opened 6.5 centimeter. Put the needle of compass on this point of beacon and then draw the circle of 6.5 centimeter. So this is 6.5 centimeter circle. And at least 2 kilometers from the coastline. Coastline is a straight line, and 2 kilometers from one straight line, it is parallel line. 2 kilometers is equal to 2 centimeter. Open the compass 2 centimeter. Draw one arc 2 centimeter away from this point, and one arc from this corner, and the next arc from this corner, and the last one from this corner. So we have drawn our 2 centimeter arcs from each corner of this coastline. Now join the top of these arcs and then join the last one. Okay, so let me color this portion blue so that we will get the clear idea which locus is 2 centimeter away from the coastline. So I made this portion blue and this one blue because to get the idea of that locus which is 2 centimeter everywhere from this coastline. It is 2 centimeter from this side, 2 centimeter from this side, 2 centimeter from this side, and 2 centimeter from this side. So this blue locus is basically a parallel path from this coastline. Now let's repeat this question. So fishing boat can only operate when they are not more than 6.5 kilometers from the beacon. So what does this not more than mean? It means that they should be, the locus which is 6.5 kilometer from this beacon is this circle. So the fishing boat should not go more than this boundary. So it means that they can fish on this boundary and inside the boundary. Therefore fishing can be done on this boundary and inside the boundary of that circle. So this is the region where fishing can be done. All this from the coastline to this circle. Okay. The second condition that it should be at least 2 kilometers from the coastline. What does this at least mean? That it should be 2 kilometers or away from the 2 kilometers from the coastline. So the fishing should be done on this parallel path or beyond this parallel path. So the final intersection of the regions are, let me shade that region. So this is the required region. So in this region, the fishing can be done beyond this parallel path, and it should be inside of this circle. But the border of the circle is the part of the region, and this path of this parallel path is also the part of the region. Now we have to label this region F. So this is F region. This whole region is F. A map is drawn to a scale of 1 centimeter to 5 kilometer. The diagram below shows a position of two radio masts A and B on the map. This A and B are the two masts. A third radio mast C is north of line AB. North is upward from this line. So the third radio mast C will be on the upward direction of this line AB. This mast C is 40 km from A and 50 km from B. Using ruler and compasses, construct triangle ABC. Now with the help of this information, we have to construct triangle ABC so that we will find the point C where we have to put mast C. The point C is 40 km from A. According to this scale, 40 km is 8 centimeter. Now we have to draw 8 centimeter line from A. Open the compass 8 centimeter wide. Draw an arc. This point C is 50 km from B. 50 km mean 10 centimeter from B. Now we have to draw an arc 10 centimeter from point B. So after drawing an arc of 10 centimeter from B, so we got point C. By joining C with A and B, this is the triangle. In part B, a house D inside the triangle is more than 35 km from B. 35 km from B, B is a point, so 35 km from one point is a circle. 35 km is basically 7 centimeter. So 7 centimeter from B. So we have to draw a circle from B, 7 centimeter radius. Now we have to draw a circle 7 centimeter wide. So as the house is inside the triangle, so there is no need to draw the whole circle. We will just draw, we will draw the part of that circle which lies inside the triangle. So we will draw a circle that will be inside the triangle. So this is the locus of a circle. Is 7 centimeter from B and inside the triangle. And this house is closer to B than A. So to draw this, it is closer to B than A. So we have to draw first the locus which is equidistant from 2 points A and B. So first we draw a locus which is equidistant from 2 points. The locus which is equidistant from 2 points is perpendicular bisector. This line is perpendicular bisector of line AB. Now we will read this statement again. A house D inside the triangle is more than 35 km from B. So a locus which is 35 km from B is circle. So this is the arc of that circle. So the house is more than 35 km from B. So the house will be outside of this arc. It will be on this side of the arc. It will not be inside the circle. That is on left hand side of this arc. And this house is closer to B than A. So the locus which is equidistant from B and A is the perpendicular bisector. If somebody is on this perpendicular bisector, its distance from A and B will be equal. But if an object is towards this side, on the right hand side of the perpendicular bisector, it will be closer to B than A. And if that object is on the left hand side of this perpendicular bisector, suppose in this region, so the object will be closer to A than B. But here the house D is closer to B than A. So it means that the house will be on the right hand side of this perpendicular bisector. Now by joining these two informations, so we are going to find the intersection of the region that is more than 35 km from B and closer to B than A. More than 35 means it will be on the right side of this arc, and closer to B mean that it will be on the left side of this perpendicular bisector. So which area will be the required region? So first we have to identify from the arc that what are the regions which are right side of this arc. So it can be this region and this region, which are on the right hand side of the circle. So if house D is in these two regions, it will be more than 35 km from B. But as the house D is closer to B than A, so if the house, so it should be on the right hand side of the perpendicular bisector. So out of these two regions, this region is on the right hand side of the perpendicular bisector. So this is the required region. This is the intersection of the regions which fulfill both the conditions. Therefore, shade the region on your diagram that represents the possible position of the house D. This is the required region D, and the house will be over here. Lastly, it is said that a house D inside the triangle is more than 35 km from B. More than 35 km means the house will not be on the circle curve. If it is on the circle curve, it will be exactly 35 km from B. So the house is more than 35 km from B. So house will not be on this curve. So we will draw this portion of the circle in broken lines. In the similar way, the house is closer to B than A. If house is on this perpendicular bisector, it will be at equidistant from A and B. As it is not on the equidistant, it is closer to B. So this portion of the perpendicular bisector will also be in broken line. Three shops A, B and C are such that B is 800 meter due south of A, and such that C is 1600 meter from B on a bearing of 120 degree. A map is being drawn on a scale of 1 centimeter to 200 meter. The position of A, B and C are shown below. So these are three shops A, B and C, and this B is towards south of A, and C is at the bearing of 120 degree from B. Another shop D is 1200 meter from C, and it is on a bearing of 57 degree. So these are the two information to find the location of the shop D. So it is better to draw the bearing first, 57 degree, and then we will achieve the line which has 57 degree bearing from point C. So to find the bearing of 57 degree from point C, we have to draw north line at point C first. As we know from the question, this B point is due south of A. It means that the point A is due north of B. So this is the north line. So we have to draw another north line at C that will be parallel to this north line. To draw a parallel north here, we will use another approach to draw the parallel line. If two lines are parallel, so these two angles are alternate angle, they are equal, and the sum of these two angles are 180. So you can draw a 60-degree angle, and with the help of that you can draw a parallel line here, which will be a north line. So using the parallel line concept, I just marked 60-degree angle here. Now I will join this point with C. This will be another parallel line to this north line. Now we will find the bearing of, that is 57 degree from C. So the bearing is, it is an angle clockwise from the north side. So here 0, 10 and 57 will be over here. I put the mark on 57 degree angle. This is 57 degree bearing. And the shop D is also 1200 meter from C. That is, according to this scale, 6 centimeter from C. Open the compass 6 centimeter and cut this line up to 6 centimeter. And this is our point D. Which is 1200 meter from C at the bearing of 57 degree. So we have to draw the bearing first and then cut that bearing line up to 1200 meter, that is 6 centimeter. In the part B, a new shop is to be built equidistant from B and C. Equidistant from B and C, it is perpendicular bisector of B and C. To draw the perpendicular bisector of B and C, open the compass more than half of this line, half of the line BC, and draw arcs on left, upside and downside of the line BC at point B and C. So this is line bisector, perpendicular bisector of this point B and C. At this line, the shop will be at equidistant from B and C. Its distance from B and C will be equal when the shop will be on this line. And this shop is nearer to BC and BA. So for the time being, we forget this word nearer. We just concentrate on these. It is equidistant from BC and BA. So BC and BA, here B is common point. So it means that these two lines are intersecting line. They intersect at B. A locus which is equidistant from BC and BA, it is from two intersecting line, that is angle bisector, and here it is angle B. Now we have to draw the angle bisector of angle B. We have drawn this angle. Now open the compass little bit more, draw one arc here, and from this point draw second arc over here. This line is angle bisector of angle B. Now in the third information, it is at least 1200 meter from C. For the time being, forget this at least. Just read 1200 meter from C. 1200 mean it is 6 centimeter from C. 6 centimeter from C is a circle with radius 6 centimeter. Open the compass 6 centimeter and draw a circle of 6 centimeter radius. Now we will read this question again, the B part again. A new shop is to be built equidistant from B and C. So the locus which is equidistant from B and C, that is this perpendicular bisector. It means that shop will be on this line. The second, it should be nearer to B, C and BA. So what is the locus which is equidistant from B BC and BA. This locus is angle bisector. If shop is on this locus, it will be at equal distance from line BA and line BC. But the shop is nearer to BC than BA. It means that the shop is nearer to BC. It means that the shop is towards this position. It should be on the right side of the angle bisector. If it is on the right side of the angle bisector, it will be nearer to line BC as compared to line BA. It means that shop will not be in this region. And this shop should be at least 1200 meter from C. That is 6 centimeter from C. So the locus which is 6 centimeter from C is a circle. This circle, the shop should be at least 6 centimeter from C. At least mean it should be upon this circle, or it should be beyond this circle as well. The shop will not be inside the circle. So by joining all these three information, by constructing three loci corresponding to 1, 2 and 3, find where the shop could be built and label the extreme position S and P. So according to all these three informations, the shop can be on this perpendicular bisector. It should be right side of the angle bisector, that is downward to this line angle bisector, and it should be above the circle or on the circle. It should fulfill all these three conditions. So can you guess where these 2 points would be? Okay, the 1 point will be here, S. So this S point is fulfill the three conditions. It is on the right side of this angle bisector. It is also on this perpendicular bisector, and it fulfills the third condition. It is at least 1200 meter from point C. Can you guess where would be the second point? And second point will be over here. The diagram below is a map showing a coastline ABC, a lighthouse L, a point P. This is the coastline A, B, C, and this is the lighthouse here, and this is point P. Scale of map is 1 centimeter to 100 meter. Ships must not sail within 200 meter of the coastline nor within 200 meter of the lighthouse. Construct the locus of points 200 meter from the lighthouse L. Construct the locus of points 200 meter from the coastline ABC. A locus which is 200 meter from lighthouse L, it is a circle. It is 2 centimeter circle from L. So this is a circle from L. And a locus which is 200 meter from coastline ABC, it is parallel path, that is 2 centimeter away from the coastline. And this is the parallel path which is 2 centimeter from the coastline. And you know that from the previous question how to draw this parallel path and the circle. In this last part, a ship sailed from the point P on a bearing of theta degree. So there is a ship over here, and this ship has to move from this point with some direction which is given in the shape of the bearing, and this ship passed between B and L. This is point B and this is point L. The ship has to pass from between these 2 points, from here to here, and we have to complete the statement in this answer space that this theta, which is the bearing of the point P, the ship, the minimum value of that bearing and the maximum value of that bearing. Because ship has move from point P, and it has to move between the point B and L. But there are two restrictions. The ship should not enter below this line, below this parallel path. It should not come into this region. And also the ship should not enter below into the circle as well. So we will draw one bearing from this north position in this direction, and the second bearing will be on this direction. And both these lines will be the tangent to this curve, which is curve of the parallel path, and the second bearing will be the tangent to the circle. Then we calculate with the help of protractor the angle from this north line, and it should be clockwise to both of the lines. So the first angle is 24 and the second angle is 44. So the bearing would be 24 and 44. So if ship want to pass between point B and L, just fulfilling these two conditions, so the minimum bearing required is 24 and the maximum bearing 44. If it try to move less than 24 bearing, then ship has to pass inside this parallel path, which is not allowed. If ship try to move more than 44 degree bearing, then ship has to move inside the circle, which is the restriction, that ship should not come inside the circle. So here we will write 24 and here the 44. The scale drawing shows two coastal towns A and B. The coastal town A and the coastal town B. The scale of drawing is 2 cm to 1 km. Measure the bearing of B from A. We have to measure the bearing of B from A. First we have to join the path A and B. This is the path between A and B. Now we have to measure the bearing from clockwise. So this is 0 angle, and from here up till this, the angle is 115, 60 and 115.5. Therefore the bearing of B from A is 115.5 degree. So we have to give the bearing in 3 digits, so it is 116 degree. Draw the locus of points equidistant from A and B. It is perpendicular bisector. This is perpendicular bisector of line AB. A rock C is known to be less than 4 km from B and nearer to A than B. So 4 km from B is a circle. It's an 8 cm circle. It is nearer to A than B. So a locus which is equidistant from A and B 2 points is a perpendicular bisector, which we have already drawn here. A rock is known to be less than 4 km from B, and less than 4 km means the rock should be inside the circle, and it is nearer to A than B. Nearer to A, if the rock is on this locus perpendicular bisector, it will be equidistant from B and A. As it is nearer to A than B, so it means that rock will be on the left side of the perpendicular bisector. If it is on the left side, it will be nearer to A than B. So according to two conditions, that rock will be less than 4 km, that is inside the circle, and it should be nearer to A than B, that is it should be the left side of the perpendicular bisector. Therefore the rock will be in this shaded region. As the rock should be less than 4 km, that is inside the circle, so the boundary of the circle is not the part of the locus. So that's why this portion of the circle will be broken line. Similarly, the rock should be nearer to A than B. If the rock is on this line, it will be equidistant from A and B. So this line will also not be the part of the locus. So that's why it is also a broken line. So the rock will be in this region, excluding the boundary lines. And the shortest possible distance from point A to the region C is, it is approximately 1.9 to 2 centimeter. A board D starts at the point 3.5 kilometer due south of A and sails on a bearing of 75 degree. 3.5 kilometer according to the scale is 7 centimeter and it is due south of A at a bearing of 75 degree. This point is 7 centimeter from A and it is towards due south of A, and now we have to draw a 70 degree bearing at this point. Now this black line is 75 degree bearing. Therefore, if board D starts at 3.5 kilometer due south of A and sails at 75 degree at the bearing, so that board will be on this black path. So the board will be moving on this black path. So draw the path of D and state with a reason whether it is possible that D collides with C. C is the rock. And from the previous part we have checked that rock will be in this shaded region. As the path of the board D is moving inside the shaded region, so there is a chance that there is a possibility that the board will collide with the rock. In this question A part, we have to draw triangle ABC with this given information. AB 6 cm and angle BAC is 110. BC is 9 cm and this is triangle. On your diagram showing your construction line clearly, construct the position of the point X which is equidistant from A, B and C. One point which is equidistant from 3 points we have discussed earlier, it is circumcenter. To draw a circumcenter we have to draw perpendicular bisector of A and B first, then B and C second. Perpendicular bisector of AB is this blue line, and this line, blue line, is the perpendicular bisector of BC. Both these perpendicular bisector meet on this black point. This is circumcenter, and the distance from this X to C to B and to A are equal. This X is the locus which is equidistant from 3 vertices of the triangle. C part, measure and write down the length AX. It is 4.8 centimeter. On the same diagram, draw the locus of points on the same side of BC as A, at which BC subtend an angle of 110. The locus of the point will be on the side, this side. The locus of a point such that angle line BC subtended 110 angle at that point is a circle property. Suppose this is line BC in the circle. Therefore, the point P which is moving on the border of this segment of the circle, it will make angle 110 wherever it go on this path. This is angle 110. Now we have to draw only this portion of the circle. So to draw this circle we need a radius and the center. This point is the center of the circle, as we know that the distance of this x from B, C and A are equal, and open the compass from x to B. This is the locus of point B. Answer this question on a new page. A and B are two Coast Guard stations with A due north of B. This A is due north of B. On your new blank page, mark A in a position near the top right hand corner as shown in the diagram on this diagram. The distance between A and B is 140 km and scale is 1 cm to 10 km. So we have drawn point A and B, and A is the due north of B, and this line is 14 centimeter. So we have marked point B and have drawn the line AB. Construct the locus of the point west of AB that are equidistant from A and B. Equidistant from A and B is perpendicular bisector, and it should be west of AB. And this is the perpendicular bisector of line AB, and locus which is 90 km from B, that is a circle from point B. So we have just drawn that portion of circle which is required for our locus. No need to draw the whole circle. A ship S lies on the west of AB and is nearer to AB than B and within 90 km of B. When the ship is on this perpendicular bisector, its distance from A and B are equal, but according to the condition, the ship is nearer to A than B. So it means that ship will be on the upside of perpendicular bisector. It will be on this side of perpendicular bisector. It will not be on perpendicular bisector. And the second condition is it should be within 90 km, that is 9 centimeter of B. So what does this mean? It means that the ship can be on this circle or inside of the circle. On your diagram, shade the region in which the ship is situated. So by the both of the condition, the intersection region will be this shaded region. In this shaded region, the ship will be on the circle or inside the circle, or it will be nearer to A than B. It is also known that the bearing of the ship from A is 204 degree. On your diagram, mark the two extreme positions S1 and S2 of the ship. So if we just extend this line to show the north side, this angle will be the bearing 204 degree from the clockwise direction from the north side. This line is at the bearing of 204 from A. As ship is in this shaded region and it is also on the circle as well, so that this line cuts this region at this point, minimum at this point and maximum at this point. Measure the angle S1 B S2. So join these lines to measure the angle S1 B S2, which is 10 degree. The bearing of ship from B is x degree. Find the least possible value of x. So the bearing of the ship from this point B, so this is the north line. This is the bearing of first position, and this is the bearing of the second extreme position. This second bearing is the least bearing from the point B. So we will measure the angle of this second bearing only, because the first bearing, which is the bearing of this line, it is greater than the bearing of this line. So we have to find the bearing of this line, which is 336. Construct the triangle ABC in which AB is 11.6, angle BAC is 104 degree and side AC is 7.6. Measure and write down the length of side BC. So this is side triangle ABC drawn from the given data, and by using the ruler the length of BC is 15.3. On the same diagram, draw the locus of points equidistant from A and C. Locus which is equidistant from 2 points, it is perpendicular bisector. In a similar way, the locus of points equidistant from B, C is perpendicular bisector of BC. This line is perpendicular bisector of side BC, and this straight line is the perpendicular bisector of side AC. Both perpendicular bisector meet at this blue point, and we know from our previous lectures that where the two perpendicular bisector of a triangle meet, that point is called circumcenter. Draw a circle through A, B and C. Circumcenter, and the length from this center to any one corner of a triangle is a radius of the circle. So we have drawn this circle, that is called circumcircle. Measure and write down the radius of this circle. Radius of the circle is 7.9, which is the length from this center to any vertex of the triangle. X is the point on the same side of BC as A, such that triangle XBC is an isosceles with BX is equal to CX. X is a point on this side. This is the line BC, and X is on downward side of BC, where A is located. A is located on this side of BC, so X is on this side. X is on that position so that it makes an isosceles triangle with the help of side BC. Isosceles triangle means its two lengths will be equal. If X is on this perpendicular bisector, its distance from C and from B will be equal. So wherever the X is on this perpendicular bisector, it will form an isosceles triangle. And suppose if point X is over here, even then it will form an isosceles triangle. So wherever the X will be on this side of the perpendicular bisector, it will form an isosceles triangle. But we have to find one point. The second information about the point X is that angle BXC will be 104. X can be over here, anywhere on this perpendicular bisector. But we know from the circular properties of the circle that angle subtended by the same arc will be equal. An angle subtended by this chord BC on the circumference of this circle is 104. So if we draw another angle subtended by the same chord BC at this point, this angle will also be 104. So wherever this point will move on this arc of the curve, this arc of the circle, the angle will remain 104. According to the circular property, the property is called angle in the same segment. Therefore, by these two conditions, that the triangle must be an isosceles and angle must be 104, the point X will be on this arc of the circle, and it should form an isosceles triangle. So in that case, the point X must be on this perpendicular bisector. So by using the both information, the final location of the X will be over here. If X is over here, it is on the perpendicular bisector, so its distance from B and C will be equal. That is, it will form an isosceles triangle, and the angle of that isosceles triangle over here will be 104 as well. So it will fulfill both the condition. So this is point X. Mark clearly the point X on your diagram. That is over here. Construct the triangle PQR in which QR is 9.5 centimeter, angle PQR is 35 degree and PQ side is 9 centimeter. Measure and write down the length PR. This is triangle PQR from the given data. By measuring this length by the ruler, so this length is 5.5 centimeter. On your diagram, draw the locus of points equidistant from Q and R. Locus which is equidistant from 2 points is perpendicular bisector. So this is the perpendicular bisector of line QR. Draw the locus of points. These are points on the same side of QR as P, at which QR subtend an angle of 80 degree. So the locus of the points will be on this side, on the left side of QR, because it is mentioned that locus will be on the side where P is, so it will be on this side, on this side. Angle subtended by this chord QR on the locus is 80 degree. So this is the angle property of a circle. This is the chord, suppose this is the chord QR. So wherever the point P will be on this arc of the circle, its angle will be 80 degree always. And this is called angle in the same segment or angle subtended by the same chord. Right now it is QR. If we check this angle by the D, it is also 80 degree. Now the question is, the problem is how to draw this circle, because angle on this circle subtended by the chord PQ will be 80 degree. To draw this part of the circle, we need center of this circle and the radius of this circle as well. We know that the two perpendicular bisector of the sides of triangle, where they meet each other, that point is called circumcenter. So for that purpose, we also have drawn this perpendicular bisector of side PQ, and both meet over this point. So this is circumcenter, and just the distance from this center to any vertex of the triangle is the radius of the circumcenter, circumcircle. So using this center and the radius equal to the length up to the any vertex, we have drawn this circle. We have to draw only this part of the circle because this is our required locus. So this is the part of the circle which is our required locus. Construct the triangle ABC in which AB is 12, angle ABC is 50, BC is 7 centimeter, and measure and write down the size of the angle ACB. This is triangle ABC. On your diagram, draw the locus of the point within that triangle. It is within the triangle, that is inside the triangle, which are 9 centimeter from A. That is circle of 9 centimeter from A. So from A we have drawn, this is the circle 9 centimeter away from the point A. So we have to draw that part of the circle which is inside the triangle as per the requirement of the question. And 5.5 centimeter from B, this is another circle from B. So this is the part of that circle which is 5.5 from the point P. The locus which is 2.5 centimeter from AB. A locus which is 2.5 centimeter from one line, that is parallel line. So this is the parallel line which is 2.5 centimeter from line AB. Mark and label on your diagram a possible position of point P within the triangle such that AP is less than equal to 9. That distance of that P, whose locus we are going to find, distance of that P from A is less than equal to 9. AP is less than equal to 9. So the locus of point P from A is less than equal to 9. It means the point P will be on this circle, or it may be inside of this circle as well. And the second is that BP is less than equal to 5.5. It is the locus P whose distance from B will be equal to 5 or less than 5, less than 5.5. So the locus P whose distance from this point B is 5.5, that is on this circle, and it is also less than 5.5, that is inside of this circle. Sorry, the area of the triangle PAB will be equal to 15 centimeters square. The locus of the point whose area remain constant, that is 15 centimeters square, is a parallel line. What is the gap of both the parallel lines? So we will use this information, the information of the area of the triangle. In this triangle PAB, AB is the base. This is the AB, and we know from the information the length of the AB is 12 centimeter. It means that the point P will be inside the triangle somewhere. So the triangle formed with the help of this line A, B and P will have base AB, and there will be some height. So we have to find that height. As the area is 15 and area formula is this one, just plug in the values here. The base B is 12 and this will give us H 2.5 centimeter. So the height of that triangle will be 2.5 centimeter, which we have already drawn in our previous part of the question. This is parallel line which is 2.5 centimeter away from line AB. So what does this mean? It means that the point P will also be on this parallel line. So using all these three conditions, so the point P will be inside of this circle and inside of this circle as well, and it will be on this parallel line as well. So it means the point P will be anywhere this portion of the parallel line, this portion of the parallel line. So I just marked only one point because we have to mention only one position. So I put P over here. You can put P anywhere on this portion of the line. The C part, a point Q is such that AQ is greater than or equal to 9 centimeter. So here Q is the locus point whose distance from A is 9 centimeter, that is circle, and it is more equal to or greater than 9 centimeter. A circle from A is this one. So the locus of Q will be on this circle. The Q will be on this circle, or it may be right side of this circle as well. But it should be inside the triangle according to the given condition in the question. Also, BQ is equal to greater than or equal to 5.5. So B is the point and Q is the point of locus. So the locus, the distance of locus from B is, that is circle, is greater than or equal to 5.5. It means that the Q will also be on this circle, or it will be on the left side of this circle as well, away from this circle. So if it is on the right side of this circle, so the distance of the Q from B will be more than 5.5 centimeter. And the third condition, the area of the triangle QAB should be greater than or equal to 15 centimeter square. So we have observed in the previous part, when the area is 15, it is a parallel line whose height is 2.5 centimeter. So in this case, the area is more than or equal to 15 centimeter. So it means that Q will be on this line, or it may be on the upside of this line as well. On your diagram, shade the region in which Q must lie. So by using all these three information, we have to see where the region would be. That is, it can be in this region, and in this region. Here, in this region. Q will be in this region. And according to second condition, the Q should be on the left side of this circle as well. Left side of this circle. So what is the left side? This is the left side of Q, which fulfill the first condition as well. So this is the only region where you will be right side of this circle, left side of this circle, and you will also be the right side of this circle in this region. And you will be above this parallel line as well, so that your area will be greater than 15 centimeter square. So this is our required region. This is our required area for point Q.